All right, I want to start things off here by saying ignore this call trace in my dmessage logs. It looks like this is actually from my video card driver and has nothing to do with what I'm about to talk about. It just doesn't like me plugging in my display port. All right, so I made a kernel module because my laptop has secure boot. If I do dmessage grep -i sec, you can see I've got secure boot enabled. And if I look for Hibernate, somewhere, it doesn't matter. You'll see right now. If I do systemctl hibernate, it'll fail. You can see up here, I've got my my kernel message that says systemd lognd tried to run hibernation. It's restricted. You can't do that. I've also got this other script called check hibernate. I'll just show you what that is. It just does a tail, shows me the contents of these files in a nice formatted output. So syspower state is the file that you can write to in order to put your computer into either standby or hibernation. Standby is mem. Hibernation is a disk. You can see it's not actually showing up as an option. I don't remember what freeze is, but that's not important for this video. And then syspower disk controls how the computer, basically how the computer shuts down when it's in hibernate mode. It can either do it in a platform-specific way, or it can just shut off completely. But you can see those aren't options. If I do, I'm going to go over here. I'll just do a make clean. See, I've got all these warnings because I'm using Gentoo and my my modules are built by the package manager. But that doesn't matter. This still works. You can I just ignore this warning. And I'll actually show you the module and the important parts. I included everything from security.c, which is why I've got so many includes here. I didn't feel like going through and figuring out which ones I actually need. If I remove all of them, then this stuff doesn't work. I also took this define out of security.c, and it is needed, and also this define. Well, this define is needed later. And the define needs this struct. Well, actually, it needs the security hook heads struct pointer, which is in security.c, but like isn't exposed normally. So we've got to deal with that in the kernel module. I have this function pointer. This function pointer is to get the kallsims lookup name function. Which is what this function does. This grabs the kallsims lookup name function and then assigns it to this function pointer, which is just, it's null referenced now. So if you dereference this, it'll brick everything until you run this function. And then it has this status flag called no hibernate, which is also in hibernate.c or hibernate.h. This no hibernate flag can get set by stuff in the kernel. It is not used by kernel lockdown though, so I am going to check it in my kernel module. So the first thing we do is we resolve this kernel kallsims lookup name. We use this function here. It actually goes and registers a kprobe in order to get the address of that function. And then here you can see here's the kprobe that we were returned when we registered it. And it has the address in it, and we just assign that as a function pointer to the KLA variable that we defined up above. And we return 0. So that's just sort of an initialization function. Next, we have the actual patches. Here is the patch to hibernation available. If I var temp maybe is it power? No, kernel power. And whoops, I think it's in hibernate.c. Yeah, if we go in here and look at hibernation available, here's the function. I actually patched this in this version of this kernel. Let me actually open the unpatched kernel. It's not patched in my running kernel. Here we go. So you can see here is the hibernation available function. And it checks some stuff. It checks if security locked down with a value of lockdown hibernation returns anything except 0. It checks if secret memory is active, and it checks for the CXL mem active. I removed the secret mem active out of laziness. I should fix that. But here, you can see I'm not doing that security locked down check. But even if I was, I actually also patch the security locked down. I could probably get rid of my live patch hibernation available and just patch security lockdown. I'll show you what that function looks like. If I can spell security.c. So you can see here we've got this array. It's kind of an enum. It's not really. Oh yeah, no, this isn't an enum. There is an enum somewhere. But anyway, this is an array. This just defines the error message that you receive. And you can see here this lockdown. Lockdown hibernation is there. And then if I do security locked down, here's that function. This is a very, very simple function. It just returns. So security locked down, it has this the argument, what, the reason why it's not going to allow you to do what you're trying to do. And it does this call int hook, which is what this crazy define up here is. This call int hook. I don't know how this works. I don't care how it works. It was somebody else who knows what they're doing made that. I don't know how these crazy things work. All right. Hibernation available, security lockdown. All I do is, instead of just returning call int hook locked down 0 what, I say, okay, if what it, first of all, I send a message to dmessage. And then I say, if the what is because of hibernation, just return 0. Like, let whoever's asking think that we can just do whatever for hibernation. But everything else, continue actually securing the kernel. All right. And then here we define a bunch of stuff that you need to do in order to make a live patch. What is this? Get no hibernate. Oh yeah, this is a function. This is another initialization function that just gets that symbol no hibernate using the KLA that we got earlier. So first we resolve KLA. Oh, you know what? I probably don't need to do that twice, but whatever, it's fine. And then we do no hibernate is equal to the value of KLA returns a pointer. So we cast that as an int pointer because we happen to know that no hibernate is an int, which is an integer. So this is changing this variable because it's a pointer. It's changing the address stored inside of this variable to the address of no hibernate within the kernel. That's important. So we want to get the value. We need to get the value somehow of this variable that's stored in a memory address that we have no idea about. So we have to use this KLA function in order to get the address from the kernel. The kernel will tell us what the address is. It has instrumentation for that purpose. Then we say, if that failed, if this is null or -1 or whatever, if it's not 0, sorry, if it is 0, I guess, if it's null, then it says that failed, return eno_int, module won't load, fail completely. Otherwise, return 0. Next, get security hook heads. This does the same thing, but instead of getting an int, we get a pointer to a security hook heads type struct, or or flavor struct. It's not technically a type because I have to put struct in front of it, but that's a C whatever thing. If you know C, you know what I'm talking about. Same thing, check for a null pointer. If it's a null pointer, fail, bomb out, don't load the module. And then here's the actual initialization function. So this runs as soon as you load the module. It's defined, it's executed by these magic things down here that are sort of, I guess, a kernel module prelude type thing. So we've got a couple of variable definitions. We check get no hibernate. We say, okay, if there's no error, so if the error is less than 0, it will be less than 0 if it's an error. Return the error, don't load the module, fail. Same thing for security, get security hook heads, don't load the module, fail. And then we enable this patch, this KLP enable patch, which is a function that's defined in one of those includes, probably for live patching. It is kernel live patch. That's what KLP stands for. So it enables the patch. We give it a pointer to the struct that we defined to patch, which is way up here. Oh, here we go. So KLP patch. This module is a magic symbol. It just says it's this module. And the objects is another struct, which is this one here. It says, okay, we're going to patch these functions. Here's a pointer to the functions. And here's the functions struct. And we give it an old name. The old name is hibernation available. That's a string. And then we give it a pointer to we give it, I guess, the actual function, live patch hibernation available, which is defined inside this C file. Same thing, security locks down. That's the function we're replacing. We're replacing it with the one that we wrote. Easy peasy. So that's enabled. If it returns 0, something failed, bomb out, don't load the module. Otherwise, we patched hibernation available. Sweet. Return the return value, whatever we got from KLP enable patch. That's probably going to be a 0 for success. And then now the module is loaded. Then when we unload the module, we just say, yep, we unregistered it. It's gone. Cool. We give a license, module description. And we have to tell the kernel at load time that this is a live patch. So that's what this module info is for. All right. That's an explanation of that. Yeah, there we go. So we're going to make this. And then you'll see it builds, no problems. We can ignore these warnings. And then we can do, if we do go over here, lsmod, grab unlock. You can see it's not loaded. But if we do make install mod, it will actually sign. Here we go. Actually signing this module because my kernel requires that modules are signed in order to load them. And okay, yeah, it's trying to remove the module first because you can't really load it. It has the same name even. You shouldn't load it on top of itself. So it unloads it first. It doesn't matter that fails. And then it installs the module. So now if I go back over here, lsmod unlock, there you go. You can actually see here. Where is this? Oh yeah, resolved, stuff, enabling patch, unlock hibernate, starting patching transition, patching complete, patched, sweet. So, and actually if we want to check if it actually finished, what you can do is take this. This is a user space kernel interface. Whoop, there we go. And you just cat this file. If it returns 0, that means it's not enabled. The patch won't work, or the patch won't do anything. And if it's a 1, it's enabled. You can actually also echo 0 to this file. And then I can just do my check. See, it's not active, but if I check lsmod, it's actually still loaded. So I can just echo 1 again to this file. Ooh. Ooh. Oh, interesting. Okay, fine. You can't do that. I'm wrong. Just, I don't even need to do that. I could just do mod probe. There we go. And I could cat that file again. And it's 1. So check Hibernate. You can see the result here is different. We have disk under syspower state. That's a thing now. And under syspower disk, it no longer says disabled, which is what it said up here. It now says platform, shutdown, reboot, suspend, and test resume. So I'm going to leave it as platform. And did I run systemctl hibernate? Yeah, you can see up here it failed. Okay. So I'm going to do a hibernation. And actually, just for fun, I'm going to echo hello. Do that just so that there's something else on here too. I'm going to go up to my D message, give it a couple carriage returns, and systemctl hibernate. If you don't have systemd, you can just echo disk and redirect it to syspower state, and that'll do the exact same thing. So I'm just going to hit enter. You're going to see color bars. I'm going to see my computer go to sleep. Actually, not go to sleep. My computer is going to effectively power off. It's doing a platform-based hibernation, so the power LED will do something weird, but it's going to power off. Theoretically. Oh, hibernation exit. Interesting. What happened here? Odd. Let's try that again. Why is hibernation exiting? That doesn't make any sense. Fine. We'll do it the other way. Actually, no, let's do this. We're going to echo shutdown to syspower disk, because that worked for me before. Now if I do check, you can see it's now shut down instead of platform. No, I don't want that. Systemctl hibernate. There we go. Let's try that again. You can see even when I echoed, I don't know if you saw it, when I echoed shutdown to syspower disk, the security lockdown function actually got called because it had to check to make sure I was allowed to do that. And these kernel messages are just generated by my module. So that's how I can tell that my module is actually working. All right, let's try this again. Hibernate. Come on, let's go. What is going on? This is infuriating. Yeah, reset. This is a systemd thing, isn't it? Let's do this. Echo disk to syspower state after setting back to shutdown. Come on, work. Okay, that one worked. So my laptop has a bug apparently with the platform form of hibernation. That's not super important. The point is, hibernation worked. You see color bars. My laptop is off. I'm going to press the power button now. This is going to take a minute. I see my BIOS. I'm going to see the systemd bootloader in a moment. As soon as Draycut loads, you'll actually see messages from my init RD or my Draycut initial loader thing. And that thing is going to use, so my laptop has secure boot. It has a TPM. I use the TPM to unlock the disk keys if secure boot verifies everything correctly. And I use my own home-built secure boot keys So you can see it just went ahead and finished Lux, which is the encryption, full disk encryption. My swap partition is on there. And before I can even finish, I'm already back in my desktop. So there you go. The hibernation worked. Now, if I scroll up here, you can see. Did I wait like any amount of time? Where is it? Yeah. Hibernation entry. Pre-allocating image memory, blah, 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 blah. Disabling non-boot CPUs. Bunch of security freeze lock stuff for the disks. Memory killer re-enabled. Hibernation exit. Here's my hibernation exit. And then a bunch of devices had to get reinitialized, like my Wi-Fi and stuff. So now if I do check again, whoa. You can see it's still enabled. So the important things for this to work is this kernel module must be loaded into the kernel during the init-rd. So I had to put something into etcdrake.conf.d flags. I had put this force drivers in here. I had to install the module, so I had to do sudo make install, which actually loads it into lib modules, whatever. And it has to be signed again because of my kernel. And if you want to trust secure boot, actually, technically the whole init-rd is signed. So even if somebody placed a bad module in there and you didn't have module signing, it wouldn't work because they couldn't actually get away with it. The bootloader would detect that signature change and it would fail because it would have to be signed with my secure boot keys. And again, the bootloader is signed with my secure boot keys. And the firmware won't boot anything that isn't signed with my secure boot keys. And the TPM won't unlock the disk unless all of that has gone through. So like if you went in and like somehow factory reset my BIOS and like put your own secure boot keys in there, that would change the secure boot keys and the TPM would say, whoa, stuff changed. You are not allowed to auto unlock. Like you have to enter your password. I'm not having this. So there you go. Now if I do make rmmod again, that just unloads that kernel module. And if I do check, you can see again, it's back to failing. Hibernation is restricted. And if I try to echo disk to, what is that? I'm just going to do this. Operation not permitted. Hibernation is restricted. You're not allowed to do that. Kernel lockdown doesn't let you. And if I actually look at the man page like it tells me to, do that again. You can see, there we go. Unencrypted hibernation. See, this is misleading. Unencrypted hibernation or suspend to swap are disallowed as the kernel image is saved to a medium that can then be accessed. Yeah, that's true. It is true that unencrypted hibernation, suspend to swap are disallowed. The problem is that my swap is encrypted. It's underneath the Lux encryption. So why doesn't it let me? Well, the answer is because if you have secure boot, or rather, if you have lockdown enabled, it doesn't even matter if you have secure boot. If you have lockdown enabled, it just doesn't allow hibernation, period, ever. So this statement is sort of technically incorrect. Even if it's encrypted, it doesn't allow you to hibernate. So I had a problem with that. I wanted to be able to hibernate with my encrypted swap partition. The reason it's a swap partition is that when you hibernate, everything that's in RAM gets written into your swap. So your swap has to be at least as big as, I don't think it actually has to be as big as your RAM, but it has to be big enough to store everything that's I guess, important to the current running state of your machine. So if you've got like 64 gigs of RAM, but you're only using like, 3 gigabytes or whatever, your swap can be smaller. My swap is the same size as my RAM, and I try not to let stuff go into swap, or if it is, it's just because of, it makes disk caching work better. And Hibernation is smart enough to say like, oh, we just won't care about all the disk caching stuff. We'll get rid of that, and we can move stuff back into swap. So that's why it uses swap. That's why it cares. That and the security implications. So this kernel module is on my GitHub. I have a big disclaimer. It says like, you need to know what you're doing if you load this. There are good reasons why. There are good reasons why the Linux kernel developers put that security safeguard in place. Overriding it is probably a bad idea. Overriding it the way I did it is probably also a bad idea, especially since I'm disabling some other checks. Like specifically, what was it? I don't remember the actual check, but here we go. Yeah, the secmem, the secure memory active. I'm not checking if secure memory is being used. So I'm sure there's a reason why the kernel does that. I should probably add that into this module. Again, I could probably just I might try this later. I could probably just completely get rid of the Hibernation available live patch and rely entirely on patching security locked down, because this is called by Hibernation available, and that's literally what I'm patching out of it. So I might do that. That would be a little better, because then I'm only checking if it's checking for Hibernation, which is a lot better. Yeah, I'm going to do that. But in the meantime, I wanted to make a video. So this went a little longer than I expected. Hopefully this taught you something. I didn't know about, or how, I think I've heard the term kernel live patching before. I didn't know how it worked. I didn't know what it did. I didn't know what the purpose of it was. This is not the purpose. The purpose is not to defeat security functionality in the kernel. It's actually to allow you to patch a running kernel to be more secure. But, all tools can be used for purposes other than the intended ones. And this is one of those cases. I wanted to be able to hibernate my computer, and now I can. All right. Have a great day. Thanks for watching.